Use slope-intercept form to sketch a graph of 3x minus 2y equals 8. This isn't in slope-intercept form as it is. We have to get y alone on one side of the equation. So our first goal is going to be isolating y on the left-hand side. To start, we need to subtract 3x on both sides. This leaves us with negative 2y on the left, and then 8 minus 3x on the right. Then to get y alone, we have to divide by negative 2. That means we're going to have to divide all of the terms by negative 2. This leaves us with y on the left. On the right, 8 divided by negative 2 is negative 4. And then the second term is going to end up being positive. Those two negatives will cancel, the subtraction and the negative. And we end up with 3 halves x. So we have y equals negative 4 plus 3 halves x. Again, this is good enough to figure out the slope and the y-intercept, but technically, slope-intercept form has the x term before the constant term. So we can move that 3 halves x first, and then the minus 4 afterwards. Now either way, the slope is the coefficient on the x term, and in either of those, that's 3 halves, so the slope is 3 halves. The y-intercept is the constant term, in this case that's negative 4. And once we have those, we can sketch the graph. We start by finding negative 4 on the y-axis. That is our intercept. And then we can use the slope to get more points. Starting with the y-intercept, the slope is 3 halves, so that means we go up 3 and to the right 2, and that'll give us another point on the line. So we have our point there. And then from there, we can go up 3 and to the right 2 again. That gives us another point. And we can do it again and again. Up 3 and to the right 2 takes us here. Up 3 and the right 2 takes us there. And then if we go back to our y-intercept, we can go down 3 and to the left 2 to get one more point, this time in the third quadrant. Once we have our points, we can connect them with a straight line. We can label our graph, 3x minus 2y equals 8. And we are good to go.